I have three things that I want to put on the table because there are a lot of other folks on this call that can also bring attention to the answer to your question. The first is, we're thinking about curiosity-driven or discovery research. We're also talking about use-inspired basic research and development. And we know, as you said, the private sector has a part to play, philanthropic institutions have a part to play, but the federal government has a huge part to play here. And they therefore looking at this simple ratio, R&D to GDP, research and development divided by gross domestic product, it's just an indicator of the amount of attention and activity we're paying to these important aspects of our innovation system. And so at the first blush, it's really important to understand that these advances and investments in advances in our discovery and solution processes, that is what's picked up to some degree by this indicator. Now, that doesn't mean that only the federal funding matters. It certainly is a basis for a lot of activity that occurs even in industry and with the support of philanthropic institutions. So it's at the core. And again, we're looking at solving major issues here and also discovering what the genesis of those problems are that affect our human condition. What do I mean by that? Issues pertaining to health, as you said, security, and usually we think of national security, but we're also talking about food security and water security. We're talking about environmental quality, and we're talking about all of these elements and more for all of us here in the United States and around the world. The second item I would put on the table is talent. Why do we care about how much we're spending on research and development within our economy? And that's because some of it actually goes to our talent. I'm sitting here at a university at Georgia Tech, and I see those investments all the time. I was actually on a phone call with students this morning about not just these investments. They don't necessarily see that distinction, but boy, when you hear about what they're doing, the productivity that's coming from the students and the talent that's being grown, that's an important aspect of these federal investments in R&D. So that's another piece that's really important. Investments in our education, that's important to continued growth, not just starting things up or standing up new programs or new exploration areas of exploration, but it's also really important for continued growth. We're talking about STEM education. We're talking about traineeships. We're talking about investments in not just research ones, but research to universities, developing centers of excellence in subfields that are linked to existing strengths in a strategy for maximizing both outstanding work and assuring its broader geographical distribution all across the United States. The only other thing I will add for now is that all of this requires us to be able to know at the end of the day, how did we do? What was the impact? Did we really discover new things and also apply our talents to understanding and developing new solutions? And I think that part of that is also the investment in the data infrastructure to, at the end of the day, know how did we do? So in summary, I want to say we want to remain on the leading edge of technological innovation. To do so, we need government investments in areas that A, give a major return to the public, and B, are risky enough that the private sector does not necessarily see initially that value in that investment.
NSF has been a tremendous resource to the nation. If you look at the genesis of NSF, when Weaver Bush in 1945, when he set forth the vision for what NSF can do, and then it was launched 70 years ago, 70 plus years ago, in 1950. If you look at even this moment of COVID, for example, if you look at the PCR test, or if you look at the CRISPR technology, all of that is coming to very handy in this moment of very important moment of rapid detection of COVID, for example. This is not just happenstance. It doesn't just happen, even within a decade in terms of research explorations. These are several decades of what Kaye alluded to, which is what I call curiosity-driven, discovery-based explorations or exploratory research. Now, these explorations then sometimes take within a decade, maybe even a few years, to translate into very valuable outcomes and outputs. Sometimes it takes several decades. So this intertwining of curiosity-driven, discovery-based explorations and use-inspired, solutions-focused innovations, that is the DNA of NSF. That's how I characterize it. Highly synergistic, highly symbiotic, and NSF has been at it. And even take, for example, the 3D printing technology. Even undergraduate students, expressing their unbelievable innovative potential by using that to print rapid PPE equipment. This started in 1980s as an additive manufacturing kind of a focus that NSF put in place. So over the several decades, my predecessors and the fantastic folks at NSF and the scientific community has made possible these tremendous innovations that have been put in place.
You talk about doing things differently coming, and I mentioned at the outset that there are these pieces of legislation that are making their way through Congress. And one of the goals here is right now we're spending about 0.7% of GDP on research and investment, on research and development. And in the 1960s, it was up around 1.9%. President Biden has suggested a goal of around 2% of GDP. And Kaye talked about at the beginning that these numbers mean something. They're important because we can take some of that and actually invest it in people and also in different ways of funding science.